So now that you know how to balance reactions, let's talk of different types of reactions. We have the simplest version, and that is a single displacement reaction. And this sort of does exactly what it sounds like. One atom kicks out another one or displaces it. And you see in this reaction down here, Fe starts off on its own, and copper is connected to sulfate. So Fe comes in and says, hey, I want your spot, and ends up connecting with the sulfate. And then copper is displaced. So that would be what we call a single displacement reaction. One of the more common types of reactions that you should be able to see and predict the products and then balance all of these equations is a double displacement reaction. So if you want to consider this, copper here and sulfate are pairs, and iron and nitrate are also pairs. Well, if you want to look at the metals, we have copper here and iron here, versus the anions, or the negatively charged things, are sulfate and nitrate. So notice that where we start with copper sulfate, the copper metal that we start with ends up combining with that other anion, or the negatively charged thing, in order to give you, in the end, copper nitrate. Now remember, how we get the subscripts is different than how we balance the equation. These subscripts right here come from the charge on the metal and the anion. And so it's not necessarily the same as it is on the reactant side. Okay. Meanwhile, we have this iron here, and it's going to react with and pair with the sulfate in the product. And that's how we end up with iron sulfate. You might need to practice some of those to make sure that you can predict what the products are and get the right formula, and then balance things, okay? The next is a precipitation reaction. Now, some of these things, you could have a double displacement reaction that is a precipitation reaction. That's totally fine. So this is sort of a type of double displacement reaction most commonly. This is something that forms a solid or a precipitate, and therefore we call it insoluble. And so we just kind of already talked about that a little bit. So you should know how to write an ionic and net ionic equation of this type already. Cool, so we've already done some things that you've already seen before. The next type of reaction is a gas-producing reaction. This does exactly what you think it will do. It produces a gas. And the gas that can be produced is, it doesn't even matter what it is, but the point being, you get a product with a G in the end, or a gas. Next, we have combustion reactions. Combustion reactions are things that combust, or you would think of as burning. And these all require oxygen, most commonly are with some type of hydrocarbon, in other words, something that contains carbon and hydrogen, and you produce CO2 and H2O as final products. Next, we have acid-base reactions. Now, these are an entire field of reactions that honestly, when you're starting off in general chemistry, can be super confusing, and it's hard to understand and identify. So please know that that is a common frustration. I remember feeling that way too. So be patient. Over time, you're going to learn these more, and it's okay if you struggle with it a little bit at first. But what an acid is an acid is something that dissociates. In other words, it comes apart into positive and negative forms, and it's going to make H3O+. The reason being, if it has H+ hanging around and that adds to H2O, that's going to give you this H3O+. So sometimes we use this H+ and H3O+ sort of synonymously. In other ways, not so much. H3O+ is really the right way to say it. So some of these acids are strong, and what that means is that they dissociate completely. In other words, they're so ready to get rid of whatever it is that they're attached to, they're like, see you later, bye, okay? And they just sort of separate. Others are kind of happy being where they are sometimes, but then they kind of want to dissociate too. So we say that they partially dissociate and they partially stay together. And so that's the difference between a weak acid and a strong acid. Strong acids are dangerous, right? Bases usually are a metal and OH, at least strong bases are. So strong bases are of that format. Weak bases, those are harder to see at first, and it's okay, but they usually contain nitrogen. That's the easy way to know it for now, okay? So I wrote out some reactions for you down here. A strong acid might be an example, just HBr, and see how it goes to H3O plus and Br minus. Here's the big part. See how this arrow goes in one direction? That means it fully happens. The reaction fully happens. Versus a weak acid, it still produces H3O plus and an anion. But see how there's arrows in two different directions? You might see something like this too. Those mean the same thing. And what that means is that the reaction doesn't fully go forward. It can kind of go forward and then most of it can stay on one side or the other side, but it's not happening in full. And so it's not a strong acid, okay? Next we have weak bases, or strong bases, excuse me. And that would be something like LiOH, NaOH, CaOH2. Those are all strong bases, and they separate into Li plus and OH minus. But on weak bases, when we have a weak base, like NH3 and H2O, you might say, why is that arrow not a double arrow? Guess what? It should be. And so we end up with NH4 and OH minus there as well. Other types of things that you should know about acids and bases is what are the strong acids, the common strong acids, and what are the strong bases? Well, strong acids include exactly what I've written here. And yeah, you have to know them. So HCl, HBr, HI, nitric acid, sulfuric acid. I wrote that twice, it's so important, sorry about that. H3PO4 and HClO4. Those are the 1, 2, 3, 4, 5, 6, 7 strong bases that you really need to know. Or sorry, strong acids. And we have our strong bases. These are the ones that's more common. KOH and AOH, LiOH, and CaOH2. And so when an acid and base come together, that causes what we call a neutralization to occur. And so an acid and a base come together and they produce a salt. Guess what? You've been doing salts all along. An ionic compound is a salt. And water. So anything that's charged would be a salt. So say that we have NaOH and H2SO4. The Na combines with the SO4 to make the salt, and the OH and the H combine to make water. Okay, good job. To balance this, I really should put a 2 there. The final type of reaction that you need to know is something called an oxidation reduction reaction. Now, this is its own category and kind of can get more complicated or complex. So just know that that works, and I'll follow up on the next video as to what this oxidation reduction reaction is and how to go through and know what they are. Okay, see you soon.